All right, picking up where the last video left off talking about function notation. You've actually probably seen some function notation before. Function notation just talks about when instead of saying y equals 3x minus 8, for example, you say f of x equals 3x minus 8 because y is a function of x. Y depends on x. X is independent, y is dependent. And when we have f of a number, that simply means to replace the number in the x spot in the equation. So right here, we write the equation just as we see it right above. We take out the x and put in parentheses so we remember where the variable was standing, and we replace it with the number 2. And then we simply apply what we remember from way back in August with PEMDAS. We need to multiply first, which gives us negative 8 plus 7, and further simplifying, negative 1. So f of 2 is negative 1. And if I were to want to write this as an ordered pair, that means when x is negative 1, when x is 2, y is negative 1. Because we let x equal 2. What if we let x equal negative 3? So right here I have f of x, which is negative 4x plus 7. And you can see we're putting a negative 3 in here. So f of negative 3, when I compute, I get 12 plus 7, which is 19. But notice the problem didn't ask for f of negative 3. I mean, it did, but it asked for f of negative 3 plus 1. So I need to plus 1 on the end of that. And when I do that, I get 20. So f of negative 3 plus 1 equals 20. Let's try a few more down here. F of 1 would be 2 times 1 minus 3. Instead of 2x minus 3, 2 times 1 minus 3, which is 2 take away 3, which is negative 1. 6 take away f of positive 5 rather. Well, first we need to go off to the side and figure out what is f of 5. F of 5 means 2 times 5 minus 3, which is 10 minus 3, which is 7. So now I can put that right back in. I'd have 6 take away 7, which is negative 1. So the only part that's substituting in is just the f of 5. F of 5 is 7. Everything else stays the same. 6 minus f of 5. 6 minus f of 5, which is 7. Down here we have f of negative 2. That would be 2 parentheses. Put a negative 2 inside, which gives us negative 4 minus 3, which is negative 7. This next one is the most complicated. First we have to do f of negative 1, so 2 times negative 1 minus 3, and we have to do f of 2. So again we have f of 1 right here, and we have f of 2 right here. Again, using PEMDAS, we have to multiply first, which gives us negative 2 minus 3 plus 4 minus 3, and then working left to right, negative 5 plus 4 is negative 1, minus 3 would be negative 4. We can also plug values of x into functions that aren't linear, because back in Unit 3 we learned all about quadratic functions. So we can simply substitute this x value right into our equation for t, because we've changed the t into a 4. So I'm going to rewrite my equation, but everywhere that I see the letter t, I'm going to take it out and just put parentheses to hold the place, so I remember where to put this number. Next, I'm going to substitute. 4 goes everywhere that there used to be an x. And now we have to apply PEMDAS. I'm just going to rewrite this so that it's all one color. Think about how you use PEMDAS. You could also use your calculator right now. That's not cheating, but it's also good to be able to manage some mental math. P and E, parentheses, exponents. I need to handle squaring my 4. So I end up with negative 16 times 16 plus 68 times 4 plus 2. Order of operations will help you here. 16 times 16 is negative 256. And this would be 272 when I do 68 times 4. And finally, plus 2 on the end. Working from left to right, let's see, if we do 272, take away 256, we end up with 16 plus 2, which is 18. Next, they want 2 times h of g. Well, we haven't seen this happen yet, where we had h of t, and now they want us to find h of g. Well, just like we've been doing, we're just going to rewrite the h of t function, and everywhere I see t, I'm going to take out the t and put parentheses, just like you would do if it was a number. But it's not a number, it's a letter. So I'm actually going to put a letter in for a different letter, which might seem kind of silly, but I'm going to replace my g for the t and simplify as best I can. So negative 16g squared plus 68g plus 2. This is h of g. But part B asked us for 2 times h of g. So if I want 2 times h of g, I need to do 2 times on the right side as well. And I need to distribute. So 2 times the h of g function gives me negative 32g squared plus 136g plus 4. So that's 2 times h of g. We started with the h of t function, took out t, put in g, and then we doubled everything because the problem told us to double our answer. All right, just a few more to practice, and then we will be finished with our step 26 notes. On this one, f of 4 means rewrite the f of t function. Take out t and put in 4. PEMDAS tells me to cube the 4 first, so 4 times 4 times 4 is 64. So we have 2 times 64, which is 128. F of negative 5, rewrite the function, take out t, put in a negative 5. Parentheses are essential when you're evaluating functions like this. If you don't type parentheses and you have even powers, things can get messed up. So this tells me negative 5 to the third power is negative 125 times 2 gives me negative 250. This next one calls for 3 times f of t. 3 times, I'm going to take out f of t right here and put in the entire f of t function. The entire f of t function is 2t cubed plus 2. Now we just simplify this a little bit more. We would multiply 3 times 2 and get 6t cubed plus 2. That one was the hardest one. How's that one feeling? Does that make sense? 3 f of t plus 2. 3 f of t plus 2. We're just putting the entire function into the equation. And then finally, we want to do f of -3. So I wrote my f of t function, but I took out t, left a parking space, and put in -3 minus f of 1. I'm rewriting f of t. I take out t and put in 1. And then we simplify. 2 times -3 cubed is -27. 2 times 1 cubed is just 1. So -54, take away 2 is -56.